So we have started a factoring checklist. What is the first form of factoring that you always have to look for? And you're going to notice that we're going to talk about this checklist an absolute ton. Michael, what is the first thing we look for? The greatest common monomial. What is the second thing that we look for, Beth? We look for a difference of squares. What is the third thing that we look for, Kira? And now for the fourth thing. The fourth thing that we look for is called a binomial pair of factors. Now there are two ways to do these. One is the connected math rectangle area model, and that will work. Although I can see from today's investigation that many of you were wanting to get rid of the rectangles as soon as possible. I'm going to show this using rectangles, and then I'm going to show you the old school algebra way that I learned when I was in 8th grade. Cool. All right. So we're going to start with a trinomial, an expanded form trinomial that we are going to factor. So let's start with x squared plus 10x plus 24. So we're going to go through our checklist. First, is there a greatest common monomial that we can pull out? Is there a number or a letter that goes into all three of these terms? No. You'll tell me that 2 goes into these two, but not this one. You can tell me x goes into these two, but not that one. So we don't have a greatest common monomial. So the next thing that I look for is a difference of squares. You'll remember that a difference of squares typically is a binomial. The first and the last term are perfect squares, and it is subtraction. This fails on all three counts. 24 is not a perfect square. It is not a binomial. It is a trinomial. And we have no subtraction at all. So we know it is not a difference of squares. Then we look for a square binomial. A square binomial is always a trinomial, where the first and the last term are perfect squares. X squared, is that a perfect square?
Yes.
Is 24 a perfect square? No. There's no whole number multiplied by itself that equals 24. It's close, I mean 25. But so we do not have a greatest common monomial to factor out. We do not have a difference of squares, and we do not have a square binomial. So there has to be another way of factoring, and that is finding a binomial pair of factors. First, the area model method. So here we go. We have our rectangle. I'm going to draw it out, and I'm going to subdivide it into 4 sections. And so what I'm going to do is I'm going to supply the areas of the pieces that I know for sure. Any guesses what the area of this section here is going to be? Sam?
X squared.
Yeah, absolutely. And incidentally, how do I get x squared? So this has to be x, this has to be x, because x times x is x squared. I happen to also know the area of this piece here. What is the area of that piece right there? Alec? It is 24. Incidentally, it will always be this last term, and this will always be the first term.
Like every single time?
Yes, all the time. And the trick is always going to be trying to find the areas of these side panels and the length from here to here and the length from here to here. So here's the question. My 2 blue rectangles have to add up to a certain number. What do they have to add up to? Aiden?
10.
Not just 10, but
10x.
10x. So the sum of these 2 rectangles must be 10x. So here's the question. What times what is equal to 24? But when you add them together, we'll see. Marcos?
6 times 4.
So you're going to say this side length is 6. So 6 times x is 6x.
Success.
So what will this be here?
4x.
Not 4x. This will be 4. So x times 4 is 4x plus 6x is 10x. So therefore, this trinomial will be equal to a binomial pair of factors. What are the two factors? What are the two factors? Sarah?
Well, it'll be x plus 4 and x plus 6.
And where did you get the x plus 4? Where did you get the x plus 6?
Well, so x plus 6 is the base length, and so then the height is x plus 4.
Years of practice. The bracket, I'm sure. All right. Now, there's another way that I like to do this. This is how I was taught. I was taught to make something called a factor sum table. I'll show it to you. I personally don't really care which way you do this. We'll work on the same problem. So I said we need a factor sum table. So we're going to write a table. Obviously, I'm not doing this for my health. If I think it's important enough to write, you think it's important enough to write. So I'm looking for factors. And I need factors that multiply together that equal 24. This is the same thing as this right here. And then I need a sum of the factors that is equal to 10. All right. So let's list some factors. I know what the answer is. You know what the answer is. You at home know what the answer is because we just did the same problem. But let's list out all of the possible factors. Kira, give me one. 1, 24. 1 plus 24 is? So nope. It's not 10. Give me another one, Nick. 3 and 8. 3 plus 8 is?
11.
That's a big old nope. Livy?
6 and 4.
6 and 4 is?
10 and yes.
So obviously this is going to work. You know, if I really wanted to be diligent, which I'm sure you wouldn't do for your homework, you could do 2 and 12, which has a sum of 14. That would be a big old nope. Let's see what else. I think that is all of them, because I could flip them, but you know the sum's going to be the same. So then what you do is 6 and 4 work, so it's x plus 6 times x plus 4, and that's it. So I don't care which method you use, as long as you get to the right answer.
I like the QBQ.
So let's try another one.
Where do you get the x from there?
Oh, because we know that x times x has to equal x squared. We know that has to be the first term in the binomial. All right, yes, Livy.
Okay, so is this kind of like the problem we did last night at Math Help, where you had to like check your answer? So that's like
Yes.
how you check it.
Yes.
Okay.
So the problems, the differences of squares and the square binomials can also be done this method. So if you, the rules that we talked about in differences of squares and square binomials are faster than doing it this way. But if you are really stuck with only learning one way of factoring, this method is going to work for 95% of all factoring. So this would be the way to go if you have trouble compartmentalizing different forms of factoring. Yes?
What's that table thingy called?
Factor sum table. So we're going to try another one. And we're going to do this one together. This time we're going to do one method. Would you rather use rectangles or the factor sum table? Factor sum table is the loudest. So here we go. So let's say we have x plus 7x plus, oh, I don't know, 12. I think that will work. Oh, yes, thank you, x squared. And we need to find the factored form of this. So what's my first step? What? I'll draw a table, okay. So what goes here?
Factors of 12.
It's 7.
Okay, someone give me factors of 12. Factors of 12. Margot?
1 and 12.
Give me another set of factors. Stella?
3 and 4.
Give me another one.
That's it.
2, 6.
3 plus 4.
I know 3 plus 4 is 7. 1 plus 12 is...
12. That's enough.
1 plus 12 is not 12.
Come on, man.
I'll take the line.
3 plus 4 is...
11.
Okay. So what is my answer going to be?
3.
No, it's not. Ashby?
Would it be x plus 3 and x plus 4?
Exactly. We have successfully factored this. Would you like to try one more?
Yeah, but
Okay.
do the rectangle this time.
Can we do one on our own?
We'll do one more. This time we'll do the rectangle method. And then we'll do one more on your own. Oh, you have time. Okay, go for it.
Cool.
Caught in the board. All right, does somebody want to walk us through this on the board?
Yes!
I do.
All right, the last person up at the board was a boy or a girl.
Oh, I was.
Okay, Aiden. Aiden, please pick a girl with her hand up. This is not a prom date, just pick someone to come up. Okay, Olivia, take it away.
Okay, so for this rectangle thing, you bring down this to fit in the box right here. So that's 6. And then you bring down this to go in the box right here because that's x squared. And then to get x squared, you need to do x times x. So those are the side lengths for that. And then you need to find how you can get 2 x's to add up to 5x. So, and also to get 6. So, so then it would be 2 right here, and then 3 right here. So this would be 3x, and this would be 2x, and 2 times 3 equals 6 right here. So then it would be this equals x plus 3 and x plus 2.